Today's lecture we are going to discuss about the geological process of wind. Anytime if anybody is talking about a wind activated region, then usually it comes into our mind is a beautiful desert kind of thing. Okay, so that sand dunes, that is what in the most of the pictures on the movies what we see, that it is a sand dune where the wind activity is very high. But if you see that the most prominent areas where the wind activities are acting, wind processes are highly active, those regions we call it as deserts, and the deserts are any regions which having a dry climate or an arid climate with less than 25 centimeter of rain per year. So that area we call it as a desert. So there are a number of reasons an area to become a desert. It may be due to the lack of rain because the wind carrying the moisture from sea is blocked by something, or it is far away from the sea, or there are a number of reasons that, or it is not in the wind blowing part where the moisture carrying wind is not reaching a particular part. So there are that make the land that make the surface into a desert condition where the wind activities would be very high. So if you see that in the same pattern, if you have seen about the other natural processes like rivers or the glaciers, the wind also have the process of erosion, or it have the process of transportation, and it have the process of deposition. And on this process, erosion and deposition features will be producing a number of landforms on the surface. So when as a civil engineer, where we see a region for our any kind of particular construction purpose, if you see some features which is the process of a wind activity, then it is an indication of the region was a kind of desert in the past. So the point is that when we see a region today and landform today, the surface, it is not necessary that the desert will continue as a desert only in the period of time. So there are chances the desert will convert into a vegetated land, or the vegetated land may convert into a desert. So desertification processes are going on in so many areas. So there are chances when we see a land today, so that is not a desert, but in past it might be a desert kind of environment for the that particular land. So these features what we are going to discuss today, that will help us to identify, okay, whether this area was a desert, or it is now a desert condition, or it is having a less rainfall condition, or is there any chance that this area to become a desert condition in the future. And if such kind of conditions are there, then as a civil engineer we can decide whether to construct the thing or the structure there or not, whether we are going ahead with the construction of that structure or not. Okay, so that kind of decisions we can take based on a little bit of knowledge about the geological processes of wind. So we'll take one by one. If we talk about the erosion process of a wind, this slide, I think you must be remembering that the methods of river erosion, it is river erosion. Okay, so the wind also have the same kind of erosion, but there are little bit of slight changes. Like in the river process, we discussed about hydraulic action, that is a mechanism of losing and the removal of rock by water, whereas in the case of wind erosion, when we talk about wind, that process is called, it is a deflation process. So the pure wind which blowing on the surface, picking up the material from the surface, and that process of erosion is called a deflation process in the case of a wind process. And other two processes like abrasion and attrition, both terminology is same. In case of river, we discussed that is because of the water and the sediment together does the abrasion, and the sediments within the water does the attrition process. But in this case here, the abrasion process is wind and the sediment that together erode the material. And I think that we have discussed briefly about what you see here. This is kind of a erosional feature produced by the wind. What happens, this rock type what you see here on the top, this is a very resistant rock type, and the wind is not able to erode, whereas in the rock type what we see on the bottom part, this is less resistant. It is more easy to erode. So what happens when the wind blows, this wind will be acting on these all parts, and the bottom part will erode more and more. Two reasons: the less resistance of the rock, and second one, this part will have more suspended sediments within it. So the process which is more going to act on this part would be abrasion process. So abrasion process is more effective than that of deflation or hydraulic action. Deflation in the case of wind, and hydraulic action in the case of a water. So the abrasion process will be more effective, so that it will be able to erode more particles. As a result, this rock will erode more and more, and it becomes a particular shape in the desert environment. So this kind of environments, or this kind of structures are common in a deserted environment where there is a wind blown features are seen. Correct. So this is three processes. What are those? These are deflation, abrasion, and attrition. Now let us see that if these are the processes, or what kind of features these processes can produce. So these are the features which are produced by the process of deflation. As I explained, deflation is what? Deflation is the picking up of sediments by the wind only. So the main landforms which are produced by the deflation process, that is oasis or blowouts. Oasis is nothing but is a depression that we usually see in the desert region. For example, if this is a desert, and this desert will have a huge sediment deposited, sand size particles or something like that sediments which is deposited, and the wind is started blowing through the surface. As a result of the blowing wind, what happens is the material from this part will be slightly picked up, and it will be transferring somewhere here and depositing here into other form, or it will change the morphology of the region. So this downward picking of the sediment, that will leave a depression. So this depression we call it as a blowout. But when it touches the groundwater, where there is a groundwater, when the sand grains or the wind will not be able to remove these grains from the saturated portion, because that gives a cohesion to the sediments. So sediments will be mixed together, and it will be difficult for that grains to erode. So the level at which where the groundwater is there, the winds will be able to remove the sand size particles. So that will create a what we call it as a blowout. So these blowouts, when some part of the water from the saturated area which will come into these depressions, and slowly what happens there, the tree or small tree or plants will start growing. So this part where the plants growing, so the vegetated portion, we call it as a oasis. So oasis is a depression formed by the blowout, but it is characterized by the vegetation which is covered by a vegetation. So depressions formed by the removal of sediment from the desert is known as the blowouts, and the blowouts filled with water is called a oasis. So these are the two main terminologies which are associated, or the landforms or the features which are associated with a blowout process. Now one more is there. What is that? Which is called a hamada. Hamada is a term which is representing that the fine grains on the surface, fine sediments on the surface, which has completely blown away, and as a result what it remains? It remains a rock surface which covered, which will be something like a polished nature, which polished means that a smoothened surface, because of the continuous blowing of the wind, the surface will be converted into a polished nature. So that kind of area we call it as a hamada. So hamada is a rock surface in desert from which thin cover of sand has been removed. So there is no sand cover. Now when we talk about the next one, that is the abrasion process. You know what is abrasion? Abrasion is the erosion activity of wind along with the sediments. So there are basically four main type of features which are produced by the process of abrasion, which are the first one we call it is yardang. Yardang is an elongated low-lying ridges. So this kind of small ridges which are elongated to the direction of the wind. So that kind of elongated portions we call it as a yardang. And the feature what you have seen in the previous slide, that is a pedestal rock. The differential erosion process of the wind. The surface, the layer, the rock in the top of the feature that will be resistant and it will stay, and the bottom portions will erode. So these kind of features are very common in the deserted environment, and there are reasons because this part will be more eroded by the process of abrasion, and whereas in the upper part it will be basically the deflation or the wind only will be eroding. So that process will be less. So that will create a pedestal rock. So this is also known as mushroom rock because of the shape. It seems like a mushroom. Similarly, vendifax. Vendifax is another small size rock fragment having one or more polished surface. So if you see this is something like a two polished surface because of the variation of the wind blowing, the direction of the wind changing, the surfaces will be getting polished. So this kind of rock type, small fragments of rock types which is seen in the surface, we sometimes call this polishing as a desert varnish. The varnish is the term what we use for polishing our wood materials. So this is a desert varnish surface. So this kind of multiple polished surfaces on small fragments of rock, we call it as a vendifax. And the last one, it is called a desert permit. Desert permit is nothing but you know what is permit. Permit is that when we do the permit. So desert, that process is done by the wind. What will this wind do? Because there are number of small fine grains which are there in the surface, but when the wind blows, these all fine grains will be blown away. Okay, so the all fine grains will be blown away, but these large grains the wind is not able to remove. As a result, these large grains will remain there itself, whereas the fine grains will go away. So that will create a particular flat surface which have covered with the rounded to sub-rounded pebbles. Pebbles means large size particles. Okay, so these are the features which are basically produced by the action of wind abrasion process. Okay, so attrition process which doesn't make any particular feature because it is on suspension. Once it is broken in the suspension, it will settle down somewhere and it will form as a depositional feature. Now the same way wind also does what we call it as a wind transportation process. So we have seen this also in the river. When the river also or the glacier also transport the material, whereas in the case of wind transport the material in three different ways. First one, we call it as the creep. We use this terminology in sliding or rolling in the case of water. Here it is called a creep. This is a large particles. They move on the ground with a small rolling action. And second one is the process called saltation. We have seen the same process, that the wind blows on the grain. This will jump. This is a one jump, and from there it will jump again. From there it will jump again. So this small jumping process, we call it as a saltation process. And whereas the fine grains, when there is a strong wind, even in our areas, you see that when there is a strong wind, we'll see that lot of dust which is picked up by the wind. So that all particles which picked by the wind, we call it as the suspension load. Okay, so these are the three different ways of transportation which the wind does. So this is the transportation process by wind. Similarly, wind also does deposition, because when the sediments which is eroded from somewhere, which is transported by the wind to somewhere, but finally it has to deposit somewhere because it is loaded with that material. So these deposition processes of the wind, what it produce two major kind of landforms. One we call it as a dunes. Okay, so dunes are the various shaped deposits of sand grades, and you know that the material or the reti what we are using for the construction purpose to make the concrete which is mixed with the cement. So that material, that size, that is a size. Sand means a particular size, and that size is around is 2 millimeter to 1 by 16th of a millimeter. So that size fragments, that diameter fragments, we call it as a sand. So these sand particles which are deposited by an action of wind, we call it as a dune, correct? Whereas the fine materials which are remaining in suspension and transported by the wind, which deposits in usually in a very low energy condition, that deposits we call it as a lowest deposits. We call it as a lowest deposit. So this lowest deposit, what we see, this is a deposit in Leh Valley in Himalaya. So if you have happened to travel through Himalayan terrains at the upper Himalayas, most of the slopes, this kind of slopes, what we see, that slopes will be covered with, that slopes will be blanketed with a thin layer of fine sediments. So that sediments we call it as a loessic deposit. These are all very fine grained sediments which are carried by the wind and it taken into the upper atmospheric level and moving towards our Himalaya. And when it reaches the Himalaya, the height is already very high, and the wind will trapped into the valleys in the Himalaya. Himalaya is having number of different valleys. So these valleys will trap the sediment, and where it will get a very low and calm environment where the wind will slowly deposit all these materials on the surface. So as a result, it will produce a loess. So this is called a lowest deposit. So lowest deposits are very fine. So there are this is how a dune actually forms, or the major parts of the dune. This is the wind which is blowing, and the sands what you are seeing here, it is a saltation process. It will go up and go up, and it will slowly deposit, and finally it will drip down, and as a result it will produce a steep leeward slope and a gentle windward slope, and the area where it breaks, this is called a crust. Okay, so this process which slowly continues, and this is the migration of the dune. Now this layer from here, it will migrate, then it will migrate further. So the dune will be migrating further and further until it gets stabilized. Okay, stabilized means the dunes get stabilized by growing by the growth of plants, or it is getting moist when it reaches the water region where the wind is not able to now erode this thing, then it will get stabilized. So unless and until this is not happening, this wind will be moving this things carry forward. So this if we are going to do some kind of construction in a desert environment, this is very essential to understand that where we are going to construct. For example, this is a large dune, and in front of that dune, if you are planning for a construction of house, okay, without understanding that the migration of this dune, which direction it is migrating, so this will be covered with the dune in the next few years if it is an unstabilized moving dune. And if it is a stabilized dune, we can go ahead. And if it is not stabilized, the first thing you have to do is that you have to stabilize that. So stabilizing the dune, there are a number of processes by putting, there are, for example, somewhere we put oil on this on the surface of this dune. So oil will bind the sediments together, or maybe put some plantations on this top of the hill or top of the mount or in the dune. So what that will stabilize the dune. So that kind of some processes needs to be done before doing the construction. So understanding that is the important thing. Now there are different varieties of dunes. For example, what you see here, this dune is called a Barken dune. So Barken dune is nothing but is a dune generally developed when sand material, the material availability, this all depends on the availability of the material, which velocity of the wind and the direction of the flow, all this together, these different varieties of dunes are forming. Okay, so this is a particular type of dune which is forming in the crescent shape in the top, and the this is the wind blowing side, and the material is not much material, or the sand grains are not available. As a result, it will create a crescent shape, and this portion where it is reaching the slope portion is horn portion, that will be pointing towards the downward direction. Whereas in the second case we call it as a transverse dunes. That kind of dunes produces when there is an abundant materials available. If more sand is available, the wind may develop in transverse dune part. Okay, so this is rather into a curve pattern. This will be a large, this will be a what we call is a large straight long deposits. And third one we call it as a parabolic dune. So where the in somewhat similar to that of the Barkan dunes, except that the deeply curved and is convex in the downward direction. So that you can see that this is formed in this direction, where the sediments in this part which is formed in the this direction, the curvature is formed in the opposite to the windward direction, whereas in this case the curvature is formed the curvature of the crescent shape of the dune is formed from the wind direction, towards the wind direction. And the last one, it is another type, that is a longitudinal wind, where the longitudinal dune, which is a symmetrical ridge of sand that forms parallel to the prevailing wind direction. So it is forming along the direction of the wind. Here it is forming across the direction of the wind. Here the crescent shape or the orientation of the crescent shape is towards the direction of the wind. Here it is opposite to the direction of the wind. So these are number of different kind of structures or the landforms which are produced by the wind and or the dune. And this is what we call it as a loess. I have shown you that loess photograph. So this is a loess deposit, a thick pile of loess deposit, very fine. Okay, and if you see a closer look, you can see this kind of this is sand particles in between, and this you see, this is very fine clay type material. And this is me sitting on the loess deposit, near the loess deposit in Leh Valley. So this is the same location. I'm taking you to the same location where I have personally seen. Yesterday we have discussed about these alluvial fans also, and today also we are going to discuss the same area, that is Leh Valley. So you know, this is the Leh Valley. This is the Indus River which is flowing, and this is the Leh airport. Okay, so here somewhere here you'll find the Leh Valley. So this is the situation, and where I have shown that photograph just now, that photograph I have shown you is from somewhere this part. Okay, somewhere from this part. So now if you see this white color, what you see here, this pure white color, these are all the fine grain deposits. So I have shown you that is somewhere from this, that photograph what I have shown I have shown you, this is from somewhere here. Okay, so this part is what where I am sitting. I am sitting somewhere. This is actually excavated right now. Mostly this part is gone, but it was something from here. Or if you see a little bit more detail, see somewhere here, see the amount of materials, the fine materials which are depositing. These are all basically by the wind blowing. See here, this is large amount of deposits. This is not a product of product of the weathering of the certificate with the surface, but rather it is mostly deposits of wind blowing deposits. Now the wind, when it blows everything, and it climb on the surface, it will blanket the surface. But at a period when there is a rain, these things will come down and it will go to the river and it will flowing here and all this part. So this is what actually happening in Leh Valley right now, but this kind of things must have happened in our region in the geological past. In the geological past I am talking about is around millions of years before. Okay, so just an example, if you take in our Vadodara district or the Narmada river area, where here is a hill, large part of hill here. So this hill and the sediments now depositing here, this might have been in the same kind of environment where the wind was blowing or something like that. But now these all are flooded regions. Another example, if you see that if we are taking you to the Thar desert region, see the large deserted regions. Okay, so this desert, you can see that how there is nothing on it all. It's a large, huge part, there is nothing. And this desert process may be extending to some part, it may be growing to some part. So that kind of processes will be also active. And in all these sediments which are carrying by this deserts, it may be controlling the climate or the deposition process on the nearby regions also. So general understanding of these all things is very essential for a civil engineer, that where we are going to do our construction and what kind of activities are there, whether it is a wind blowing area, whether it is a glacial activated area, or it is a river flowing area. So any area when you are going through, then you should be able to understand little bit of the geological history of that region from the natural